So everything you've heard about today requires physical infrastructure, right? And if you want that physical infrastructure to be reliable and performant, it's going to be in a data center. There's no getting around it, all right? So that requires power. So think PDUs, in-rack PDUs, generators, transformers, right? Think cooling, right? Those are CDUs, XDUs, manifolds in the floor, rear door chillers, direct-to-chip cooling, right? There's a lot that goes into it. The physical infrastructure is super important, all right? And what's interesting is one of the world's most critical infrastructure hubs that supports today's global digital economy is right in our backyard. It's not 30 miles from here, all right? So that's super cool, right? So what we're gonna be talking about today is that physical layer specifically and what Northern Virginia's AI infrastructure means for the region. All right, you guys ready? All right, buckle up, here we go. So I'm Adam Stone, I'm the Chief Technology Officer of the Mid-Atlantic at E+. What we do is I specialize in advisory services in and around the data center, including AI. And we got, go ahead.
Lilin Huang, the Associate Professor in the Department of Electrical and Computer Engineering at George Mason University, and also the Dominion Energy Faculty Fellow in Power and Energy Systems.
Hi, my name is Scott Wallace. I am the Head of Engineering and Architecture for Digital Realty. I was paid to say this. We are the world's largest global data center platform.
I told him he had to brag.
You did. Love that. I'm from a company you might have heard of known as NVIDIA. I am a senior solutions architect for partners in the area and things like that. I help people figure out how to translate AI kind of workloads into infrastructure requirements through different products and scoping out some of the demand there. And Adam was kind enough to ask me, to come hang out with you all this evening.
I kind of begged him. It was one of those things. All right,
sure.
Crack on. So if you're looking at demand, I mean, the data center in this area is growing like crazy. Did you want to talk a little about that first?
Yeah, I think I will talk about from the power demand. So in Virginia, as you know, that Dominion is our utility provider. So at this point, the data center load, as you know, that we heard it so many times that we are hosting the world's largest data center cluster, and the power consumption right now is 25% of the Dominion load. In the next 3 years, the load will become more than 50% of the Dominion load. If you build a data center today, place your request in a queue, you have to wait 7 to 10 years to get a connection. So that is the magnitude we are seeing. So, Forrest, what makes that demand? What creates that demand?
Sure. I think kind of unique to this region, if you think historically, this is where all of the communications went. In colonial times and all the way, into modern times, whether it was telegraphs and things like that, that's why Telegraph Road, if any of you are from, Northern Virginia area in Alexandria, that's why that's actually named after that. So if you look at some of these areas where, we have the highest networking bandwidth in the world right here. We have, historically, some of the lowest energy prices in the area. We have fantastic tax incentives for this type of innovation as well. And it ultimately, just really makes it a hub for a massive amount of investment for AI and accelerated computing at large.
And Scott, how are you keeping up with this, being from Digital Realty? Or more importantly, where are you struggling? Like, how are you not keeping up with it?
Yeah, if Forrest would stop making such good chips, we would probably have an easier time at it. But by the numbers, let me give you some stats. And we call this in the industry bragawatts. You can rename that term or any way you want, but it's kind of fun to think about. We need to level set on the size and scale that we're talking about, because as Lilin said, it is enormous. I'm not sure anybody fully realizes how big the energy demand is, and that just got accelerated by all the things that we're doing. I'm looking around the room right now, 50% of you are on your laptops, the other 30% are on your phones. Every single bit of those bits and tokens is going through a data center. Make no mistake, that's where it goes. When we talk about cloud, people usually look up the cloud lives inside of a data center. So when we talk about kilowatts and megawatts, let's orient around size first, if I can. So a kilowatt will take an average home, for example. If you live in a 3-bedroom home, that's probably anywhere from 2 to 3 kilowatts of demand you're putting on the grid at that point. A rack, a computer infrastructure rack, 8, 9 years ago was on average about the equivalent of that, 2 to 3 kilowatts. Now we are seeing approaching 250 to 300 kilowatts per rack. Per rack. These are jet engines that are fired up inside of a data center, and they are largely determined by everyone in this room insatiable, and I mean insatiable desire to consume everything all at once and everywhere. So our goal by the numbers is to make it as efficient as possible. Make no mistake, every electron matters to the data center world. It just does. Every molecule of water matters to us. So by the numbers, we operate 350 data centers, 60 different markets, 35 different countries, and we're over every continent except for one, and that's Antarctica. And I would put one there if I could get reliable power. I get free cooling.
How many DCs in Northern Virginia?
We've got 31 in Northern Virginia. We're the largest data center provider in Northern Virginia. And you're going to beat me up on sustainability later. That's okay. I'll take the bullets. Before you go there, know that I've got 100% renewable energy in my colo business at about 600 megawatts. And in Northern Virginia, I've got 1.5 gigawatts of IT capacity and load. So I'll take the bullets after the conference on the
What's
on the
about
sustainability.
the total? Like, so is it like 20 gigawatts for the whole area data centers?
For
You guys
Northern
are-
Virginia?
you guys are a
yeah,
good
it's
chunk
about,
of-
it's about 20 gigawatts, yeah, something like that. Our total IT capacity load across our asset classes, about 3.5 gigawatts, and then we have another 5 gigawatts under development, which I'd say probably 40% of that's in Northern Virginia.
So Scott, as folks are interested in, leasing some of your space, how early do they have to get in line for your data centers?
We're open for business today, okay? Forrest, that's fine. We can talk after this. We've got capacity in Northern Virginia. It is a very strategic market, as you've already indicated. By the way, you're doing fantastic things here at GMU. I got the pleasure of touring your SMR control room.
So awesome.
Unbelievably cool. So quick plug for you on that. In fact, we're bringing some Digital Realty folks in next week to do kind of a demo on it. But you asked a real good question about how are we keeping up with that demand. We're not. We're not. And that's not to scare you, but everybody in this room has a little bit of a part to play as it relates to alternative energy or differentiated energy sources. Petrochemical meets solar meets wind, which geothermal, which isn't huge in the States, it's huge in Europe. All of those technologies kind of combined in order to meet that demand. We are playing around with BESS systems, energy storage capacity systems, bolt-on capacitors, and anything that we can keep up with the demand and the thermal tolerances on my buddy on the left here and what he's building.
Is that your bring your own energy story? Is that what that's all about?
I'll let Liling kind of take the BYOG
right.
stuff. You've heard of BYOB, bring your own beer. This is bring your own generation of power. Liling, what are you thinking around that?
Okay. Yeah, so a little bit about power. As you know, power is the oldest discipline in engineering, right? It's built more than 100 years ago. It wasn't meant for this type of growth. So it's like you are buying a car, you are owning a car that can only go up to 60 miles per hour, but now you are pushing the car to run 200 miles per hour. So you can see what kind of challenge that power systems are facing. So to tackle that challenge, of course, we need power. But not only the generation, when you have a power, you have to deliver to the load. So most of the generation, as you know, it can be in Northern Virginia. It's elsewhere, for example. So that means that you have to upgrade your infrastructure, upgrade your transmission. You have a car, you have so many cars, that's fine, but you need a highway. You have to expand the highway. So we are taking multiple, approach and solutions. So build your own generation, on-site generation is one of the solutions. Because when a generation pair with a load, it reduces the losses, so you don't have to transmit through the transmission line. So that's why SMR, because SMR, it's clean, it's low carbon solution, and if you can build next to data center, that will solve part of the problem. So build your own generation, bring your own generation will become, in some country right now, is a mandate. You want to build a data center, bring your own generation.
So if you look at like short-term and long-term, so is the short-term problem more the transmission of power rather than generation, but the long-term problem we need to figure out is, it would solve the transmission problem if we could do better generation?
Right. And then so we have to be creative, because when we look at a problem, we have to look at long-term, not short-term. How long does this demand will grow? Okay. So we don't want to build a huge infrastructure, and then after a while, kind of overbuilt. So the on-site generation not only solve the short-term problem, but it could also solve a long-term problem. So we are looking at modular design. So if you have a mobile modular solution generation, so right now, while you are waiting for Dominion, I can bring the mobile generation on site. And then when you make the connection, I can move the mobile generation elsewhere. So it's like a share the resources. So that's one of the solutions we are looking for the on-site generation.
Yeah, I mean, like if you went to the GTC conference, what's a rack of NVL 72? Is that 600K a rack? Am I crazy?
Not quite that much. 72, for this next generation will probably put you around 220 kilowatts, but by the end of the decade, you could potentially see, a megawatt in a rack.
Oof.
Yeah.
I mean, demand gen, that's crazy. So okay, now's your sustainability question, right? That gets difficult here. Talk a little about cooling, just water supplies. There seems to be a big difference between perception and reality.
Sure.
And then there just seems to be a really big gap between the boardroom and the data center floor when we're talking about this. So if you could kind of, what's the reality here?
Yeah, that's fair, and I like real-world examples. If you're working on the stove with a hot pan, what is the fastest way to cool the pan down? We've all touched a hot pan before. I know I have. You don't put it on a counter and just let it cool. You put it under water. Water has a heat carrying capacity that far exceeds that of air, and its conductivity is far better than air. So when we start approaching those thresholds of high dense, and he's talking about an NVL 72, there's NVL 144s, and again, you folks just keep pushing the limit faster and faster on the GPU sets. And so we've got to figure out the thermodynamics to fix it. Water has become the de facto standard to cool anything that we consider ultra high dense. So if you're utilizing your AIs, and we'll talk about token movement in here in a minute, because every token that you move has a correlated watt function to it. Like every time you do a model lookup or an LLM or it's a chatbot or a agentic or anything, it has a token. That's the currency of AI. There is a watt association to it, and there's a power association to it. And
What'd
that power goes into the point.
Tokenomics? Is that what you call it?
Tokenomics, that's what we're naming it. There's a ratio. And so we use water in most of our data centers now in order to cool those high dense environments. There's a copper blazing plate that just does kind of the heat sink and takes it from one unit and transposes the water and sends it out. Before you beat me up on environmentals, it's closed loop water, and 90% of it is reclaimed water. So before you beat me up on stealing too much of the city's water. City water is expensive. Trust me, we will take every other alternative than city water if we can get it.
What's the golf course stat?
Oh yeah, so you love the golf course stat. Of all of our assets that we have liquid cooled, and we are seeing more and more of that, we call it DLC, direct liquid cooler, directly to chip. Over our entire portfolio of water, we use the equivalent of what 17 golf courses use. So before you beat me up on the water consumption, stop playing golf so much because you love that grass. So leave it at that. Fair?
Oh yeah, absolutely, absolutely. And when I'm working with digital, a lot of times, what I really like with some of those companies and like Vertiv and some of the other partners we work with, they really have the whole thing thought out when they're talking about modern data centers, right? They have to have a complete story, which is, think of it like an electron from the grid We got to bring that thing all the way to the chip. And then when it comes to the chip, we have to absorb that heat and put that heat all the way into the atmosphere, right? So super, super important there. Especially as, you know, and let's pass it on over to you for a minute. There's a lot of things going on just in the scientific world that's driving a lot of accelerated compute usage, right? That's not just AI. What'd you say to me earlier? AI is a subset of accelerated compute. If you can talk a little about that, that'd be helpful, I think.
Yeah, you know, so my background is in data science and machine learning. You know, I'm actually a GMU alum from 9 years ago.
Woo!
Ironically, in the biomedical engineering department, which was basically electrical engineering in disguise. And you know, I went on to get my master's in electrical engineering. But you know, back then it was just doing large-scale data analytics. You know, when the first convolutional neural network came out, you know, that was an amazing innovation. But AI has just entered, you know, a tranche. You know, just like any one of these veins, it has just tapped into the public ecosystem to a scale that accelerated computing really only stopped at the enterprise. You know, now anyone can use it as their personal assistant. You know, they can, you know, make a cat video that's like, you know, doing something funny or whatever it is that they want. But this large-scale adoption is just driving this utilization through the roof. You know, people can't get enough. And you know, even back to some of the sustainability points, even though we're talking about, you know, a single rack that maybe can get up to, you know, a megawatt or something crazy in the future, the important thing to understand there is that that is one rack that would have otherwise have taken 16 racks. So 16 times whatever, you know, that energy efficiency was, as you consolidate and get more dense, it becomes more energy efficient. Because you don't have all of these interconnects and everything else in that system as well. So not only is it less space, you know, it is more power efficient as you continue to get more and more dense. But to Scott's point, you know, direct liquid cooling is the only way that we can really cool down these chips at this point. Because, you know, you literally just can't blow air through it fast enough to get rid of all of that heat. So, you know, we're entering this era now where it's actually able to do some really powerful things. And I think the world really hasn't even thought about how it's going to look in, you know, another couple of years.
All right, excellent. So one thing, too, it's like we're at George Mason, right? You guys are building the workforce of the future. All right, so how do you guys feel about, like, the future jobs? What type of jobs get you excited for the future? Or what career is going to exist in the future that didn't exist, like, 5 years ago? You want to start there? Want to do it?
Yeah, I'll kick it off. Yeah, I'll just rattle off some. Nuclear engineering specificity is going to be absolutely gigantic. It is huge, and I'm not just saying that because Lillian's sitting next to me and she's got the, you know, awesome SMR up there. We are seeing it. We are drafting for talent in that world. EE, mechanical engineer, critical infrastructure engineer, certainly important. I tend to double-click on environmental sciences, governance, risk, said differently, environmentally engineering. Everything behind it is going to be engineering-based. With critical thinking tied very, very closely to it in mathematics and physics, in my opinion. We have reached the AI era, make no mistake. We started seeing it 8, 9 years ago, but I kind of rephrase it as this is the great energy expansion era as well. Because I tie everything back. If we do not figure out energy, then this AI ramp will stall. Unless, you know, Forrest figures out a way to the thermal capacity of those chips. So we've got to have some of the things on the front end. So everything I orient around at Digital, and by the way, I think we hired 50 new engineer capacity people in Loudoun County just last year. So in 1 year, 50 people. And we're looking for fresh, young, new, interesting talent, or old, awesome talent as well. Doesn't matter as long as you've got an interest to do something that's environmentally sound and help the world. So, well, I'm seeing those 4 and 5 fields kind of come to the top.
Yeah, for sure. Li Ling.
Yeah, what I see, so there are some engineering disciplinary engineer, like they will slow down in the future. So I see that the demand of the workforce is shifting one sector to the other. So, for example, in power sector, in the past 20 years, literally is very, very slow. It's literally nothing is growing. But now, like Dominion, that last year they hired 500 people. So people may kind of, I heard a lot of people worry about the AI may replace your job. But I think that, from my perspective, energy conservation, we just shifting from one space to the other. Like critical, infrastructure engineering, as Scott mentioned, digital engineer, we will have some new discipline that we need the talent, but those are shifting from one sector to the other. And I appreciate you thought this workforce, because to power, P is my favorite letter, power the future, we need people. And I think that, to the infrastructure without power, without people, it's just a building. It's not going to function. So even, AI may replace some jobs, but I think that they create more jobs in a way.
And a good example of that might be with your company.
Yeah. I get that question quite a bit as far as, its effects on jobs and things like that. I see it ultimately as, if high schoolers had, keyboarding courses that teach you how to type to be fast so you can be more productive, and then you learn Outlook, you learn Word to be, faster within, Microsoft Suite or something like that. It's not AI that's necessarily going to take your job, but it's someone that's using AI that, ultimately will beat you. If they are 20 times more productive and more efficient, because you're still typing code by hand, that is ultimately an easy decision for a business to make then between two candidates. But I also want to say, to your point on what jobs are changing, I'll answer it a little bit differently, because I hear the concern around computer science and things like that, because AI has kind of found this really strong niche with coding. Having the foundational skills to actually inform and guide some of these developments is extremely paramount. You have to be a delegator of tasks. People are going to enter this mindset of having to think about it architecturally to guide an agent to go do some of these things. So, I don't think it's necessarily going to make some of these, disciplines moot by any means, but it's also just going to be a matter of looking at how well AI can be adopted in any one of those disciplines.
I think a lot of this also, and you get the questions from the crowd and everything, is like kind of how you feel about AI. And that's always an interesting question to me. So we have time for a story, right? If I get wordy, kick me.
Go get it. Go
All
get it.
right, all right. So when I was a kid, I was playing catch in the street with the guy that lived next door to me. He's maybe 3 years older, right? And so we're playing catch, everything's going well, and then he's like, I'll be right back. He goes inside, comes outside with a can of gasoline and matches, pours the gasoline in the street and lights it on fire, right? And I'm like, why would you do something like this? And I remember just standing there, looking at it, going why are you doing this? Then he runs back inside, comes out with a box. He drops the box in the flames. I'm like, what's in the box? He's like, fireworks. All right, so then I ran away, all right? So what's this have to do with AI? I can tell you for sure that I'm not excited for the world to which that guy can get all the knowledge of the universe on his iPhone, right? I'm okay with them learning how to make new sandwiches. That's totally fine, all right? But so that scares me. But on the other hand, I'm also blessed with 3 smart, beautiful children, right? And when I look at their future, I like the idea of them being a knowledge leader and a thought leader, and they have this AI thought companion next to them, right? They have an idea for a company, and it's like, you know what? I can build this company. I have the advice that I need. I can start from scratch and not need to spend so much money trying to figure that out, right? So it's kind of funny, we have this world where I think the technology might just be a little ahead of our maturity, right? So with AI, it's just really important to find the right steward between the future workforce and the scary, exciting technology we have, right? And so the best steward, to me, for that relationship is going to be with people like George Mason, right? Who's more responsible than teaching our students how to use something safely, right? So super important. But over to you, same thing. It's just the feeling about the future. How are you feeling about that?
Yeah, I'm bullish with a little bit of trepidation, probably like most people. I was at London Tech Week last year, and the keynote message which was about 1,500 people. I was doing a sustainability session, and the keynote that was doing the main session was a guy by the name of John Rhys Meyers. You know John Rhys Meyers. He's Gimli. He plays Gimli in Lord of the Rings. Why he was doing the keynote for the AI at London Tech Week, I don't know, but there was a gentleman on the panel with him, and he had everybody so freaked out and so scared. People were coming out crying. I kid you not, crying, and the mood was so dull, and everybody was just this long face. And so I think the perception out there, as you've indicated, is, geez, AI is going to retire me at some point. Great, it can retire me tomorrow if it could really do my job and I could still make money. But I don't think there's anything to be frightened about or scared about. I think Forrest brings up a very good point. My story around this example would be, I've got an 18-year-old son who used Hugging Face and NLM Studio to try to cheat on a paper. It wasn't really cheating, but he ended up downloading the German legal code as his source model. He didn't get an A on that one, let me tell you, but he did learn a lot about prompt engineering and making sure he's got the right model downloaded. So there's some nuance there that makes it important. I'll give you one other example in terms of what we've done at Digital. We have no less than 10 different AI projects that look from everything from delta pressure to delta temperature, valve regulation, data center infrastructure management, and we spent a lot of money and a lot of time on the AI tools. And they came up with a couple of recommendations that increased efficiency. Then we put together a human capital group, not as a blue team, but just another team. They came up with almost 3x the efficiency once they took a step back and looked at it. That doesn't mean I'm knocking AI, but I am saying there is tremendous value in the human capital equation as it pairs with it. Alone, it's not going to work, folks. It just isn't. I spent some time with some of the folks out there at the expo, and they are all around capitalizing the probability of those LLMs and making sure that the models are correct, they're accurate, they're credible. And there's some amazing students out there that are doing some amazing things here at GMU, and that's what ties it all together. And that's what gives me really, really positive reinforcement about where this thing's going. So, my sense.
Yeah, Li-Ling, what about you? What's getting you excited?
Yeah, I'm excited about this whole AI era. AI can make our life easier and sometimes could be miserable. So we have to be careful with AI. And you mentioned about the university. So I enjoy my expertise is power, but I also enjoy working with people. And I think that all the technology, all the advancement, human is the century. And so without human, I think it doesn't have any meaningful. So in the university, we very excited. Like we are building the next era of AI technology. We are educating our future generation how to better using AI, be responsible. And at university, we have so much resource. My next door neighbor is expertise in communication. My neighbor across the hallway is expertise in policy, in economics. So at university, and then we have the wonderful industry partner to help us to build the education and research program to help shape the AI, the future. So that's what I'm excited about.
Yeah, I love it. So before I pass to you, I had a customer not too long ago that was talking about responsible AI usage, right? And they're like, I think our human resources department has a really good use case for AI, right? I'm like, all right. So I sat down with them, and they're like, all right, we want to figure out, like an example of how to hire the right people. I'm like, all right, let's crack on. And they're like, so what we did is we were messing around, and we said, how do we hire the best programmers? And what we did is a public model, and it came back with like, don't hire anyone over 40. It's like, oh great, you just committed a crime. All right. So one thing I typically really like is the NVIDIA ecosystem, right? So I think you guys do a fabulous job with guardrails and that sort of stuff. But so same thing for the future of like that NVIDIA ecosystem and how it's so well tied to the hardware. What do you think there?
Yeah, so not only are there guardrails for the models themselves, it's one thing to say please, in case our AI overlords take over one day, and you hope that they reflect kindly on all the nice things you said to them. But then, we've also rolled out things like NemoClaw, which is basically a security-hardened version of OpenClaw, and you can actually bound these models with policies. So you set them up in a sandbox so that, even if it tries to do something, like I saw an article this week, a startup had their entire, code repository deleted and all of the backups. There was poor repo management, but also, poor policy controls over some of these things. Our dedication to open source awareness so that you can just go grab the model, you can see what data set it was trained on, you can fine tune it to do kind of whatever experience there is there, and you can start small. On the smallest of small, even in something that you learn at, something that could fit in your hand, that is a petaflop of compute. It's the exact same experience all the way up to some of these data center scale solutions. And being right here, where we are geographically, where we are with industry, with all of the data centers and the ecosystem that thrives here, there is no better spot, than this region to get into this space. And even if it might not necessarily be, relevant to your discipline directly, anyone has this power now to be a coder. But a foundational expert in power, you don't have to know how to necessarily put together a fancy user interface or anything like that anymore. And it's one of my favorite quotes. Great power comes great responsibility. Sure, you can make a cat video, but that is the equivalent of leaving a microwave on for an hour. So, you have to be conscious as a user, to use it in a way that you're not just, burning tokens or using anything like that. And as we advance further and further into this new future, it's going to get easier to adopt. It will be more integrated into everything that we do. So it is important to have some of the awareness, but also how it ties into your specific discipline.
Yeah, super interesting. And it's like, I think, like with you guys specifically in that ecosystem, there is a lot of learning opportunity out there, right? And I think a lot of people don't really understand kind of the art of the possible of what we're stepping into at this point right now. I have a customer right now that they're looking at creating 3D printed lung tissue. All right, that's incredible science, all right? But it's kind of funny so how do you take something like that and then bring that all the way back to the direct-to-chip cooling, right? There's a lot in the middle, right, that you have to figure out, right? But it kind of starts with that use case, that vision, and then you have to really systematically bring that all the way back down to how to make it practical, which is really tough, right? So in a case like that, I mean, you're looking at that, it's like, all right, so tissue, all right, that's cellular fluid dynamics, right? All right, so how do we do that with computers? All right, that's Julia code. All right, Julia code, does that run on GPUs? It's difficult. Oh, unless you talk to NVIDIA, because you guys have a CUDA library for that.
Yeah,
right?
And CUDA is the master ladder of abstraction. So whether you want to, get down low and write PTX, which is, how the GPU is actually understanding some of these instructions, or all the way at the top, there are zero code replacement libraries where if people have experience with NumPy and kind of a generic Python awareness, they can literally just import a different library and leave the exact same functions, and all of a sudden the same code to do fluid dynamics is now GPU accelerated.
Yeah, it's really interesting. I think a lot of people don't really understand how that happens. Like, you guys came up with this incredible technology, and everyone's just playing video games with it, right? But only if there was a unified data architecture for compute. Oh, CUDA, right? They came up with that, and that's when their stock went bang, like just real quick, right? And that's when you guys had to really make a very fast adjustment, right? Is when these workloads started coming in. A little bit about like economics to end, maybe. If you're talking about just like liquid cooling, we keep bringing that up. What do the economics look like?
In terms of the extra costs associated with the builds?
Like, we know that like people are saying it's faster or that's going to save X amount in power. Is it accurate? Is there reality?
Yeah, it does. I mean, it's thermodynamics. The old term in our industry used to be it takes a kilowatt to cool a kilowatt, right? Kilowatt coming in power, and then you got to use a kilowatt to cool it. Those dynamics and that math doesn't check out anymore with liquid cooling. So, Some of the things that we do, this is going to sound again like we're bragging, but we're lucky enough, Forrest and I work together on pre-certifying both his equipment on our infrastructure on his equipment to make sure that that works. And so minor tweaks in what we call delta temperature, delta pressure changes, chemical makeup, the PG25, the solution we use in that DLC environment, make major changes on the output. You know, the thermal variances on your chips really need to work really well. It's a Goldilocks zone. It has to be perfect for the chips to perform it the right way, so the models perform it the right way and the software performs it the right way, and we use as limited amount of power as possible. And those formulas have to all match together. So as indicated, 7-8 years ago, we started seeing the demand spikes come in, way higher dense cabinets. We had to figure out the thermodynamics on it. And so we've got a couple of labs. You're in it, you're coming in it, you're absolutely in it, where we're testing those things in real life environments, standing up different GPU sets from different OEMs with different processing and compute power, with different technologies to cool and power, and seeing what that Goldilocks zone is. I'll say this, and I'll say it in my closing statement as well. I can't tell you how important it is. Every electron matters today. It absolutely does. So you talked about token drift and token waste. Don't waste it. Don't thank your model. It doesn't need to be thanked. You don't have to tell it great job, right? You're just passing tokens and it's burning more energy. Every molecule of water matters. It matters to us, it matters to you, it matters to your children, your children's children. I think us together collectively, that's why I love working with academia, because they're so focused on it. So everybody collectively comes together and tries to figure it out. But yeah, we're seeing it go big time spike. I'll leave you with one last stat, and Liling will laugh. This happened about, I don't know, a month and a half ago. Didn't happen here. We had a customer go from 0 to 30 megawatts in a microsecond of demand load. That's big. That's a lot. That's like 30,000 houses turning on with no advance notice. The utility company called us and didn't call us and say, hey, how are you guys doing? They called us and said, what in the hell are you guys doing over there? So everything's stepping down from the OEM manufacturer to the SMR transmission to the utility. It has to work together. It has to, or it just doesn't work at all. So that was a long way of getting there, but hopefully I got there.
Oh, it's great. So we got about 5 minutes left. Closing statement from NVIDIA?
Sure. You know, all of this stuff is, you know, it can seem like, you know, you're going into the deep unknown, unsure, maybe uncertain about, you know, how some of these things are moving. But, you know, take comfort in that we are trying to implement, you know, every engineering change possible to be, you know, as environmentally friendly as possible. For example, you know, now, instead of using, you know, cold water to cool the systems, we're actually using hot water, you know, 40 degrees Celsius. And the trick to get around that is just pumping more water through faster. And I'm saying water, but, you know, it's not, you know, full water. So that you're producing, you know, hot tub water at 3 liters per second, you know, through every single one of these chips. And, you know, to Scott's point, a closed loop system. You know, the system that is circulating through the machinery and the servers does not ever touch the outside of maintenance and things like that. So, you know, getting rid of water cooling, you know, has become a major efficiency boost. You know, we just started consolidating transceivers. So you've got these optical connections between all the servers for really high-speed communications. We were like, hey, what if we just got rid of all of the transceivers that are generating these signals and just wired them straight into the silicon itself? And then we could save 18% of an entire data center's power perspective by getting rid of millions of transceivers.
That's where a lot of the engineering comes from. If you guys haven't yet, get on YouTube and watch the GTC release recently. Just super, super cool stuff, for sure. All right, Scott, closing statement for you? Or was that your closing statement?
I closed that out with that was my big power moment that every electron matters and every molecule of water matters. That was it. I'll say it again.
Where are the T-shirts? We need every electron matters.
Table 5.
Digital Realty
I'm
T-shirts.
happy to hand those out.
Li-Ling, close us out.
Yeah, I like the word close and closed loop, right? So we are working together, you know, back to our theme, AI infrastructure to support AI future. And to close this, I want to say that, you know, to power the future, we need partnership. You know, we need to build partnership between the university the industry, the government, and the community. We all enjoy what AI brings us, but we don't want power line in your backyard. In our backyard, we don't want data center as our neighbor, but we are the user. And I think that I want to close out with we have to work together as a community, to build partnership to power the future. And where does that happen? I think university will be a very, very good place to build a partnership and then to close the loop.
Well stated. Amar, do you want to come up? No, you're good? All right. That's it, everyone. Thank you for having us.
Thank you so much. Appreciate it.